Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Chris Thayer, CEO of Motiv Space Systems. Motiv built the robotic arm for the new Mars rover, which was launched on the 30th of July and is scheduled to land on the Red Planet on the 18th of February 2021. It's a fascinating interview if you're interested in space exploration, and Thayer talks about other projects Motiv is involved in, including commercial industrial interests that the company has.
My name is Chris Thayer. I'm the president and CEO of Motiv Space Systems. In a high level, that job is fairly straightforward, establishing kind of the short and long-term goals for the company, and then making sure that we have the resources and ability to execute on those goals.
Latest specific initiative. What are the latest? What is? Well, let's start from, with a broader overview. Latest you can get onto the latest one during your answer, but give us a brief overview of the company, what kind of technologies it produces, and how it's part of. I suppose I'm looking at NASA projects. JPL, I think, is a Jet Propulsion Laboratory, isn't it? And you got a robotic arm mentioned here. All fascinating stuff. So give us a more of an elaboration of the company, what it does.
Okay. We founded Motiv in 2014 in Pasadena, which is where we're currently located, which is, as you just mentioned, JPL. We're a few miles from JPL. We're a technology company kind of specializing in robotics and motion control for space. And that was the primary motivation. But shortly after we started Motiv Space Systems, we started a subsidiary company called Motiv Robotics to try to take some of those lessons from decades of building robots for space and implement those into mobile ground robotics. On the space side, our robotics work kind of spans a number of different activities, including the robotic arm for the recent Mars 2020 Perseverance rover, which just launched about a month ago and is currently on its way to Mars.
Are we looking at this the picture of it now? Is that the
No, that's an Insight project. I think if you go see one at the bottom, yeah, there you go.
That one, okay.
Yeah.
All right. Carry on. Sorry, I didn't mean to interrupt.
No worries.
So your company built the arm for this machine, and
yes, we designed.
Where is it located on this machine? Can you point it out?
So if you're right there, the little, it's right in the front. Now that's where your cursor is right now is the science turret. So that's 45 kilograms of science payload instruments on the end of the arm. Then the arm is folded over on itself. So if you follow that white tube down, there you go.
Oh yeah. Okay.
There you go.
Excellent. Yeah.
So that's how it's stowed for as it drives around, the arm stows and then is deployed and used, and then it stows again back on the rover body.
Mm-hmm. And this is what's this lab here?
So that's the integration area at JPL, where you can see some of our engineers actually integrating the robotic arm onto the rover. It's a clean room where the rover is getting integrated, as you see there, and you see that it's a crane that's basically putting the arm in position, and then it's being bolted onto the rover.
Right. So this is JPL facilities. Your facilities, I imagine, are separate from that. Is it nearby? Is it next door or something?
We're basically across town from JPL. But yes, our facilities are separate. We developed that robotic arm in our own clean room here at our facility.
And this is probably a picture of your facility
Yes.
there.
Yes.
And how long has it been? How many years has the company been established?
We started the company in early 2014.
hmm And so that's 6 years. So have you always worked for NASA? Have you always been contracted to do work for NASA?
From as Motive, yes, I think we've had continuous contracts supporting NASA. We do work for private companies as well,
Mhm.
um, but a large fraction of our work does come from NASA or NASA contracts.
Now, the private companies you work for, are you allowed to mention them, or is it confidentiality clauses that prevent you?
Some of them I can't mention, but yeah, basically all the primes that you would know in the industry, the large aerospace companies typically are who we're contracting with.
Right, okay, that's great. Thank you, sector, for mentioning the sector. So what's the idea with, I mean, are you going to become increasingly get into the commercial or industrial side? Are you looking for more work like that away from, not necessarily away from NASA? I mean, who'd want to move away from NASA, but expand into other industrial sectors, or is that something that you want to do with? And what products would you want to do it with? I mean, this robotic arm, as you know better than me, is something. Well, both of your robotic arms would be very similar to the robotic arms that you find in factories. And obviously, when I say similar, I mean that's my level of understanding of it. I'm sure it's completely different in many ways. But is that something that you want to do? Do you want to go into the commercial or industrial, side of the economy or industry?
Yeah, so I think again, if you go up and there's a Meet the X-Link system at the top of the page, and you click on that.
Uh-huh. Okay.
Okay, so that's actually that's our X-Link robotic system, and is actually going to be launching on what's called OSAM-2. This is a fusion of some of our technology that we've had for our ground robotics development that we've done. We developed a quadrupedal robot with 6 limbs, fairly large, for doing a number of different ground-based applications, and those have been sold into various labs, including Toyota, for R&D work, and we've actually migrated some of that technology back from the ground and into the space side, and that's what you see here. That the first flight mission for that is coming up in a little over a year and a half or so, and we're delivering that flight robotic arm at the end of this year. So that's as an application where what we have seen in the industry for a long time is a need for basically the lower cost robotics, and things that are more modular, scalable, and flexible. And that's largely what we've done with the X-Link system. And so we can actually change the configuration of the arm, and then make it suitable and adaptable to various needs for space missions. And again, that system is really predicated on our ground robotics applications. So we definitely have our ground systems, which they're ground mobile systems, which we're pushing into various venues for that industrial applications that you're talking about. But we're also doing that on the space side, really trying to make robotics a ubiquitous presence in the space environment.
Right. Just dwelling on this for a moment, it's a very interesting and fascinating looking robot. First of all, I mean, I'm not an expert in robotics, but I've picked up one or two bits of information over the course of the last couple of years. How many axes does this have? Axis, I mean, as far as I understand, it's the point at which a robot can turn, like, so you got one axis here, and that allows this part to turn in this and that direction, and an axis up here, I suppose, that allows it to turn round, and so on there. So I count 1, 2, 3, 4, 5 axis, 6 axis, or what explain it
That's
to me, please?
that's degrees of freedom, and that's a 7 degree of freedom robotic arm. All three of those are configured in that way.
Mm.
Now, the good part about this, so some applications don't require that. Some applications require a 4 degree of freedom arm, or a 5 or a 6 degree of freedom arm. So we can actually change the topology of those robotic arms to meet your specific needs. And so what you see there are 7-DOF arms, which gives you a redundant degree of freedom to move around obstacles. Very similar to how a human arm is constructed. Human arms are 7-DOF arms. It allows you to reach around an object and still be able to get to the same place in multiple different ways. And that's how those are configured. But they can be configured in any form or fashion, from a single actuator all the way up through as many as you want to add. But that's how those are configured.
Now, an actuator, by that, do you mean a single degree of freedom, or okay,
Yes.
that's interesting. And is it your software that enables you to make it modular in that way, where you can add axes, and degrees of freedom? And I haven't heard something like that, you see. I thought maybe, when a robot is built, it has to be built right from the beginning, hardware and software, with the limitation of whatever degrees of freedom that it has. I'm just imagining, I never thought about these sort of questions, but you know what I mean? If you're
Yes.
building a robot and you decide right from the beginning that this is going to have 6 axes of freedom, and you build the hardware in that way, and you build the software in that way. I haven't heard of the idea of modular robot which can have extra axes or degrees of freedom added to it. What enables you to do that? Is it the software, or?
Well, certainly the software is a big part of that. You have to have the flexibility in the system to be able to accommodate changes. Now, the changes I'm talking about are not necessarily on-the-fly changes where you're just dropping and picking things up, but it's more architectural. But yeah, it's also the hardware itself. So there's a huge part of it where kind of classical systems, the way they're designed and built, are not adept at being able to change how they're integrated. So with these arms, our drive electronics are embedded in the arm. So every actuator has its controller sitting right next to it, which has a number of number of advantages. But one of them is that modularity. So we don't have to run large cable lengths across the spacecraft. We don't have to worry about those things, or housing those elements on a spacecraft. Everything is kind of contained in that arm. And so if we need to make changes, or a customer comes and they have a specific application, we don't have to do a full up development for them. We can basically just configure a system for them, and then allows them the flexibility to operate the arm that they want.
That's really, I mean, it's a very interesting robot. I've only really written about and got to know more information about robots that you find in factories. And I want to keep asking questions about what makes it different. I mean, you've already talked about the modularity. Maybe the other robots are modular as well. Maybe I should really look into that. I will. But what are the other things that are different about this robot? I mean, are the materials different? I mean, space grade kind of phrase comes to mind. Is there something tougher about it? Is there something more durable or hard wearing, or maybe more reflective of the sun so it doesn't overheat?
Right.
No, what can you tell us about the different materials or ways you built it, perhaps, to withstand whatever rigors are out there in space? That
Right.
might also be beneficial for, rugged requirements in factories and so on.
Right. So I think by and large, a lot of materials themselves are going to be fairly similar. We do have, these are lighter weight than, say, a factory floor robotic arm for sure. Um, but it's things like the radiation environment that you may be going into, or the temperature environment that you're going into, and certainly you're in a vacuum. And all of those things play a huge role in your ability to deploy kind of typical technologies into this space. So we have to select our electronics for survivability for both temperature and radiation, and like lubricants that we have to use are basically, they have to operate in a vacuum and through a wide temperature range without outgassing. So there are a number of things that are both subtle and large things that happen. The materials themselves are typically are obviously more scrutinized than you may get in a ground application for sure. But by and large, you're looking at, the arm is largely an aluminum arm. We do have special coatings on the arm and as well as what's called thermal blankets for thermal management. On orbit, things get extremely hot and extremely cold when you're facing the sun or when you're in permanent shadow. So you have to be able to accommodate that with this type of arm for that application. One of the things that we really strive for, the modularity, the scalability, all this stuff was to try to have kind of industry-leading cost and lead times. But also, it's just the value proposition for the whole system. We can essentially have the same design for a lab or commercial grade arm, all the way to a high reliability geosynchronous orbit arm for 15 years on orbit. So that means that your entire life cycle, the product life cycle from beginning to end, and beginning, I mean, when you're in the lab during formulation of your space mission, you can get a relatively inexpensive arm to start doing development on. And that development is then valid all the way through your flight system, which is unique. Usually your researchers or people developing space robotics missions are using an arm that you might be more familiar with in an industrial application, which has very little bearing on what the final mission will look like. So there's a phase that has to be repeated once you get the flight robotics in. That's not the case with this system. So we look at value from end to end as well as just the actual purchase of the system.
Right, and just to end on that difference and applicability, I was just thinking, I've always heard from fairly young age that the space program discovers things. Lots of scientists and researchers and companies like yourself discover a lot of things through building space machines and robots. Tefal, or rather non-stick frying pans are supposed to have been a result. The material that enables things to be non-stick was one of those things that came from, I don't know if it's true, but that's what I've always heard. So I'm sure there's things about this, as you mentioned, that would become more widespread, if not ubiquitous at some stage. The ability to withstand extreme temperatures sounds very interesting. And I'm wondering what kind of applications, you've mentioned aerospace, and there might be other things that it would be ideal for. Obviously, there are lots of different types of robots, not lots, but there are robots that are built by other companies. There's collaborative robots and new trend where these, whereas before big robots used to be too dangerous for humans to, touch and work with directly, be too close to. Now you got these smaller robots, more lightweight, more slow, and more like a power tool, really, that we all use, drill or whatever. So what are the kind of, can you think of any specific applications in industry that would lend itself to or be ideal for this type of robot given its extreme temperature? And is it a collaborative thing? Is it something that could be maybe reprogrammed as being collaborative? I know in space it doesn't really have to work directly with humans. It operates on its own on a remote controlled or autonomous rover, I suppose. So is that something that you can do at some point, given that it is modular?
Absolutely. It's we have torque sensing in the joints, and its payload to weight capacity is very high. Much like our ground systems, this is exactly an extrapolation of that system for flight. So the use case for this, we on the ground side, we tend to think of it as the high payload capacity arm. So as an example, our ground system arm, which is basically the same thing, weighs 23 kilograms and can lift 27 kilograms. If you have use cases where you have to, let's say, hold some heavy payload like a drill or something above head height, or you need to be able to do dangerous or complex operations outside, where you need something that's waterproof and can handle being out in the elements. That's a use case where we see the types of robotics that we design and build to be very useful. And it's also it can be done in a collaborative or a cobot kind of way, so there's a number of different ways to go there.
So obviously your work with NASA is, it's quite amazing to think of working with NASA and on space things. It's an amazing thought. How does it actually feel to be working with NASA? And is there something different about it, working with it, than maybe doing other work or something? Is there some cosmic sort of mind expanding sort of experience that you have from working with it? Or have you seen Aliens, for example, or anything like that? What's the latest mission on this list here? Mars 2020.
Mars 2020 is kind of the latest one that just launched, I guess, almost 2 months ago now. So that's the big one. I would say working with NASA, JPL, it's always a privilege every time we've gotten to do it, and the people here have been doing this type of work since the Spirit and Opportunity rovers back in the early 2000s, and I think for us, it's always an honor. It's always exciting, and every time one of these rovers or landers actually touches down on Mars, it's a very emotional day, very exciting, and you never get tired of that feeling. So
no,
we're always looking forward to the next one, and really excited for Perseverance to touch down here early next year.
So what's the current situation? It says Mars 2020. I can't remember. I know that there was a launch recently. Was there a rocket launch recently that was on its way to Mars? And where is it now? Is it already touched down and all that, or what?
It just launched about a month ago. That was probably the launch that you're remembering. and it will touch down, I believe, in February. So it's about a 7-month trip for this one.
Take 7 months to get there. Is that what you're saying?
Usually it's a 9-month. This is a slightly shorter transit time, but it's about a 7 to 9 month window. This one should be touching down in February.
Trying to find the video where it's launched. I did actually watch it live. So on this rocket, when it was launched, did you have your equipment on there? Is it on there or what?
That's correct. So up in the top, up in the little nose cone up there, the fairing, that's where the down that kind of that whole area in there.
Right.
That is where the rover is housed. It's attached to what's called a cruise stage, and so that will be that's in transit right now. And so yes, both our the robotic arm, as well as we did some camera focus and zoom mechanisms for the primary optical cameras called Mastcam Z that were also on that mission too.
And where were you at the time when this was launching? Were you there at the like the launch site or whatever it's called?
No, due to many of us had planned to be at the launch, but due to the COVID-19 situation,
yeah, of course.
We did not attend. So we watched from home. Not quite the same feeling, but certainly an exciting day for everyone here and everyone on the team, NASA, et cetera, and really the world to have this kind of thing happen. So.
Absolutely, yeah. It's amazing. Always amazing watching one of these things. So, have you been to launches before?
Yes, I've been to a couple launches before. So they're definitely fun things.
Yeah. All right. Well, yeah. In 7 months, 8 months, you have to wait to. Sorry, I don't remember exactly how many months you said, but that's how long it'll take for it to arrive at Mars. It's just amazing going to Mars. You're going to have your equipment there and it's going to unfurl or land or something. It'd be fascinating. I mean, it'd be great if you could come back and maybe you could pick up the conversation again when your arm is spotted on Mars and photographed, and I'll try and get hold of video and play it in the background while we talk. But so what do you do now? Is there something that you do for this mission now while it's in flight? Is there something that you have to check or anything? I mean, it's probably just sitting there.
For us, it's just wait and wait and hope that everything goes according to plan. And so that's it's a pretty simple job right now relative to this mission. The engineers at JPL are busy preparing and getting ready for operations on the surface of Mars. But for us, we're largely done with our job, and now we just wait and wait for the pictures to come back, as you said.
Yeah, so the guys who are now going to control it, the NASA people who are going to operate it, do they directly operate the arm through remote control, or is there some sort of level of autonomy about what the rover does when it picks up, I don't know, samples of soil or whatever material it finds? Is it something, does the rover use its camera to spot something interesting and decide by itself that I'm going to pick this up and put it in a bag or whatever, and keep it or something? What actually happens? Is there, how much autonomy does it have, and how much direct control do the NASA people on the ground have?
So due to the transit time of the communications, you're talking a 20-minute delay. So you can't teleoperate a robot. So even from the early days of Spirit and Opportunity, there was autonomy built into the system. It's like a supervised autonomy where typically if you're going to go inspect, let's say, a rock, the scientists will want to specify which rock you're going to go investigate, and then what you're going to do. So there'll be different science instruments. In the past, there's been a drill. Now we're using a coring drill. That coring drill allows us to take core samples from the rock and then store those for future return back to Earth, which is a new feature for this mission. But yes, there's a high degree of autonomy built in.
Sorry to interrupt.
It's all very closely supervised.
Yeah, sorry to interrupt, but you said to return the samples to Earth. What do you mean? During the mission, it returns the like samples it's collected. How does it actually? How would it do that theoretically?
So Mars sample return is a multi-stage event. So this first stage is Perseverance going and collecting samples and then storing them, hermetically sealing them, and then depositing them for future pickup. Another mission, a few years from now, will then go and collect those samples and then return those to Earth in a multi-stage process of collection, then going through orbit, transit back to Earth, and then collection back on Earth. And, so that's a multi-stage process, and that's an international collaboration. And that planning is just going on right now. But certainly the first stage of that is actually getting the samples, and that's what Perseverance will be doing.
Yeah, that sounds like a really ambitious but necessary and logical next step. Do you think humans will be involved at that stage, or is it going to be still robots and autonomous machines like the ones that are being sent now?
Yeah, for now it will just be robotic missions, collecting the samples and then returning them. There won't be any people in the loop until, of course, it gets to Earth. And then once you're on Earth, the great thing is you don't have to use small science instruments that you've had to put on a rover. You can use the best, the most capable scientific instruments to analyze the samples. And that's really the benefit of sample return, is utilizing much more precise and capable measurement instruments here on Earth than you could ever launch to another planet. So, and that's what the upside is, if you will, for doing it that way.
Okay, and last question about space. What are the other interesting robotic missions that you know about that are realistic or are going to happen? I remember reading a while back about robots building large structures on the moon, as preparing them for human habitation, sort of independently building things. And similarly, space stations, robots are going to build space stations, and then a few years later humans are going to go and live on them and things like that. What are the other kind of interesting robotic only missions that you can think of?
Well, yeah, there are a couple right now that are happening, that are ongoing. One is a satellite servicing mission called OSAM-1, which we are participating in. And that primary mission is doing satellite servicing, and a few other demonstrations on orbit. And then that we've been involved in from kind of the formation of Motiv. So it's exciting mission, and we're really happy to be supporting those efforts on the robotics side.
It is a very interesting mission. Sorry to interrupt, but just to elaborate on this, I remember reading somewhere that satellites generally have a fairly short shelf life, and the number of satellites that have been sent to space since the 60s and now have become obsolete and defunct has created a bit of a mess outside the Earth. I don't know if you can give us more details off the top of your head about that, but this mission is particularly interesting because obviously you know better than me. All I know is that once they're defunct, in the past, once they've become obsolete, they just float around in space, and they just, that's it. There's no way to fix them. How likely is this to happen? What are the chances? It's a very it must have been a very difficult, challenging, technical, technology development challenge. So how far along is the technology? Can it be done already, or is it ready, or what?
Yeah, so this mission is currently in development. It's funded, and it's happening. So a number of the things you're seeing on the screen now have been proven out in subscale tests on the space station, just as a preparation for getting this mission to actually go. And so, with respect to spacecraft, yes, there is a finite life, but some of those spacecraft last for 15 years, right? So it's not necessarily short, and a lot of them need to they have to have fuel reserves to what's called deorbit. So if they're in low Earth orbit, they can come out of orbit and then burn up in the atmosphere. If they're in geosynchronous orbit, they can boost up and get into what's called the graveyard orbit. So there's a number of different ways that can happen. In this mission, you're looking at a number of technologies that are going to be brought to bear. But with respect to what you're seeing here is a refueling operation. In this case, it does take fuel to keep the satellite in proper orbit. And so you're doing orbital corrections kind of constantly, maintaining your position. And since the satellites are built to be very, very reliable, sometimes the systems themselves are still functioning and are useful, but you've just simply run out of fuel. And so in this case, one of the premises here is to go up and simply refuel that spacecraft so you can get more usable life out of it. And so that's a use case that has definite value going forward.
And which part of the system is Motiv developing in this mission?
Well, I'm sorry, I didn't hear you. What was that?
Excuse me. Which part of the mission, which part of this system, overall system, which component of it is Motiv, is your company developing? I'm guessing it's the arm, but it might be something different.
It's actually the drive electronics. Yeah.
The electronics.
Yeah.
Yeah, let's talk about the electronics, because on your website there's on your product thing, you got controllers, 3 different controllers. Are these directly, they control the robot, do they? Is that what the controllers do?
Yeah, so those are all 3 different ones. We also have a 4th one that we're bringing to market right now. That's what you would see in the X-Link system. And so, yes, these are the types of systems or the type of controller cards that we would put for doing, the actual control of the arm itself.
Right, and I think last question, or penultimate anyway. Is any of it, I imagine everything is top secret and proprietary and all that. So how interoperable and, compatible is it with on-Earth systems? I don't know, communication systems. I've heard of things like Profinet or some other networking systems. Can't remember the others, but how interoperable are your systems and data sort of transfer systems and all that?
Yeah, so we use typically like a standard communication protocols for these systems. The controllers you see here, while these are built around RS-422, we also run systems on EtherCAT and really can adapt to almost any comm protocol for a given system. Yeah, so they're all adaptable to any comm protocol. It just depends on how we want to deploy them, and also what's available on the spacecraft itself. So.
Mm. And finally, I know you mentioned that you're going to be part of this OSAM project, which is absolutely fascinating and challenging, and yeah, very, very, yeah. I'm sure lots of people will be very interested in that. What are the other future projects that you're maybe in the process of developing technologies for?
Well, we're also working on OSAM 2, and that's a 3D printing job where we have a robotics system that is moving different elements around on that spacecraft. Um,
Archinaut, what's that?
that's the name of that. That was the name of the mission prior to a rename to OSAM 2.
Right. And it's a 3D, what was it? The 3D.
There, yeah. So in that mission, Made in Space is printing beams, um, and you can see there'll be a video there. And the robotic arm is helping to move the printer and move elements around to get that mission to go forward. So this is more of a manufacturing assembly mission than the last one you were looking at.
So manufacturing in space, is that what you're saying? 3D printing in space, objects that are going to be required in space?
Yes, that's correct. Yeah.
To do construction of things, or
Yeah. So what you see right there is a beam extending a flexible solar array, and that beam is being printed actively in that picture.
beam of light?
No, a beam like an
Oh,
actual.
beam, sorry, yeah, okay. All right, no, that's, I see now, I understand now. That's fascinating. Obviously, the next step is to build more complex, 3D print more complex objects and components, which then become complex constructions on a modular basis, I suppose. All right, well, that's absolutely, it's been absolutely fascinating talking to you. Thank you very much for your time. Is there anything that you'd like to add or say that maybe I didn't ask about?
I'd say one thing that just as kind of a follow-up, we will be announcing another kind of call it an unnamed project here in about a month, which will be around lunar missions, and something we're pretty excited about. It's in a collaboration with JPL. So anyway, that's can't talk about it now, but it's extreme environments, and really we hope to kind of revolutionize some of the exploration stuff that we're doing on the moon. So that'll be exciting. So
yeah, I'm sure it will. And I'll try and keep tabs on your website and see if the news comes up there. And obviously, if you want to come back and talk about it, you're more than welcome to. Be very happy to do that. But in the meantime, thank you very, very much, and have a great day. Let me just stop recording. But yeah, thank you very much, and take care of yourself.
cool. Thank you. Have a good day.
All right. Bye-bye.
Bye-bye.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.